Hello everyone, so today we're going to be finding column space, rank, null space, and dimension of a matrix. So for this question here, we're going to find a basis for the column space of A, and A is our matrix right here. So first, to find the column space, what we want to do is convert this matrix into row echelon form, REF, okay? And then once we do that, we find the pivots in row echelon form. So let me calculate the REF real quick. All right, so I calculated the REF of our matrix A here, and all I need to do to find the column space of A is look at the pivots in our REF. And once we do that, we need to correlate that with our matrix here. So see this right here, our first pivot. So our first answer would be 1, 4, 7, okay? So look. So our basis for column A would be 1, 4, 7. All right, second answer, there's a pivot in this row, and I mean this column, in the second column here, so then our next answer would be 2, 5, and 8. And there's also a pivot in this third column, so our last answer would be 3, 6, and 10. All right, so this would be our answer. This would be our answer for the basis of the column space of A. All right, so to calculate the rank of A, all we need to do is count these three vectors right here. 1, 2, 3. So the rank of A would literally just equal 3. All right, now to find the null space of A, what we need to do is find the reduced row echelon form of our matrix A here. So I'm gonna go ahead and calculate that real quick. All right, so this is the reduced row echelon form of our matrix A here, and we can see that this is an identity matrix. So when calculating the null space of A, this answer is just going to be 0 because there are no free variables. If you obtain an identity matrix for the REF of your matrix, your original matrix, then the null space of A equals 0. However, if you do have free variables, it will look much different. So let me get another example for you guys. Okay, so we have this new matrix here that will have a free variable and will have an actual answer for the null space of A. So first what we're going to want to do, we're going to want to calculate the reduced row echelon form of this matrix right here. So I'll do that real quick. All right, so this is the reduced row echelon form of our matrix A. And now what we're going to want to do, we're going to want to put our answers in parametric solution form, okay? So we're going to make our vector x equal to x1, x2, x3, x4, okay? Then what we're going to want to do, all right, so x1, what does x1 equal? x1 equals plus x3 plus 2x4, okay? So it's going to be because we got to move this one. We got to move the -1 and -2 over to the other side, so they become positive, all right? Now x2 equals -2 x3 minus 3 x4, okay? And then for x3 and x4, they're free variables, so they can be whatever we want. x3, x4, we just label it like that, all right? Then now we want to do, we want to factor out the x3s and x4s. So x3, we have 1, minus 2, 1, 0, plus x4, 2, -3, 0, 1. Okay, so this would be the parametric solution. And now, to find our answer, the basis for the null space of A would be these two vectors right there. So it would be 1, -2, 1, 0, and 2, -3, 0, 1. So this would be our answer for the basis for the null space of A. Alright, so to calculate the dimension of the null space of A, all we need to do is count how many free variables there are. So in this question here, our original matrix that we had, we reduced it and we got an identity matrix. So there are no free variables. So the dimension of the null space of A would just be 0. Alright, and now for this other matrix that we had, the dimension of the null space of A would be 2 because there are two free variables, x3 and x4. Null of A would be 2. Alright, thank you guys for watching.